Hello everyone, welcome to the session on design and analysis of algorithm. So today's session we are going to discuss what is the framework for analyzing the algorithm. So here basically before going to move this, so let me brief about what we have discussed in the previous session. So in the previous session we have discussed some of the problem solving techniques. So that is, so what is the steps for problem solving and what are all the various different problems we have, right. So based on that, so once you know how to design the algorithm and all, so next step is to analyze the algorithm, right. So as we learned in the problem solving technique, so as we know that here we need to analyze the algorithm for what reason? So for betterment of that particular algorithm. Of course, for a single problem we can have multiple solution. Among those multiple solution we need to take the better one. So for that what we need to do? We need to analyze that algorithm. So usually analysis of the algorithm can be done based on two factors. So that is, so analysis can be done in two ways. So that is time, based on the time factor and the space factor. So using these two factors we are going to analyze the algorithm. Actually in the earlier days there are the electronic computing machines, whatever they had, they are fully concentrated on the time efficiency as well as the space efficiency. But nowadays technology has been changed, and then so here we are much bother about the speed. Of course the speed of machine, so the machine is giving the result in a fraction of second itself. So but still, so we are concentrating on the algorithm which yields you the result much faster way, fully concentrating on the time efficiency. So let's see what are those space efficiency and time efficiency. So here let me take the space efficiency first. So the space efficiency of the algorithm can be defined as the algorithm efficiency depends on the amount of extra space is taken to execute the algorithm, or the extra space which has been taken by the algorithm to execute the algorithm in order to process while doing the processing. So how much extra spaces it is going to, the algorithm is going to consume. So that based on that, if you are analyzing that algorithm, then it is called as an space efficiency. So that is how much extra space it is going to take for executing your algorithm. While executing your algorithm is nothing but the space efficiency. So that means here we will one more terminology we will use, that is the space complexity. So if your algorithm efficiency is calculated based on your space factor, then it is called as an space complexity. Okay. So if the algorithm efficiency calculated based on space, then it is called as an space complexity. So if the algorithm efficiency is going to be calculated based on the space, then it is called as in, termed as in what? The space complexity. So here actually this space efficiency can be done based on it is depends on three factors, that is the program space, the different types of spaces we have, the program space, the data space, and then stack space. So here the program space. So whatever the space that is used by the machine to store the machine languages. So that is programming language. So that is called as a machine program is going to be stored in the program. So that particular space is called as a program space. Okay. So the space that is used to store the machine programs, that particular space is called as what? The program space. Okay. And then we have a data space. Like whenever we are doing some operation, definitely the operation will be performed based on what? The operands. So operands are nothing but what? It might be the numbers or it might be the variables, right? So the local variables and the constants, in order to store the constants and the local variables, we are going to use the data space. Okay. Next is the stack space. So the usually this stack space is used to store the return addresses of the program. So that means that, so whenever we are returning the values, so the parameters whatever we are returning, those data are to be stored in this particular space that is called as a stack space. So these all spaces are going to be used while executing your algorithm or the program. If you are concentrating on these terminologies, by that time that analysis is called as the space efficiency. So the algorithm efficiency is found based on the space, then it is called as what? Space efficiency, or space complexity. So what is that space efficiency is? So the amount of extra spaces that is required to while executing your program is called as space efficiency. So here we are not much bothering about the space efficiency. Now let us concentrate on the okay. So the time efficiency is nothing but the amount of time taken by the algorithm to execute your program, or else the algorithm efficiency is purely based on the time taken by the algorithm to execute it. How fastly it is going to execute your algorithm is called as a time efficiency. So here this time efficiency is going to be measured in terms of actually in order to find out this time efficiency, we have a so many parameters. So basically we are going to measure our running time based on the input size. Let us see what are all those parameters which affects the running time of that particular program. So let us see. So measuring an input size and the unit for measuring the running time. So that means that what are all the parameters which are required to calculate the time efficiency of the algorithm, or else in order to analyze the algorithm in terms of time, what are all the parameters that are depends on. So let us write one by one. So that is, so here the space time efficiency is based on the speed of the computer. It might be depends on speed of the computer, and then it's a choice of choice of programming language, and then the compiler, and then choice of algorithm, and and then the input size. So, based on these factors, the algorithm's time efficiency depends on. So, what all this? So, the first one is the speed of the computer, of course. So, whether you are going to use a 32-bit machine, whether you are going to use a 64-bit machine, or whether your computer supports a sequential programming, whether your computer supporting a parallel programming. So, those are all matters, okay, and also the choice of programming language. So, whenever we are writing a program, so that means that the efficiency is also based on the what kind of concept you have used and what kind of programming language you have used, whether you are using C or C++. So, it is also based on the time, how much time it is going to take. It is also based on the programming and also the compiler whatever you are going to use. So, both are same. So, that is the choice of the programming language you are chosen and the compiler. Based on these two factors also affects the efficiency of the algorithm in terms of what? Time. And also it is also based on the choice of the algorithm. Here we can take the example of the sequential algorithm and the parallel algorithm, and also you can consider in terms of iterative algorithm and recursive algorithm. Okay, so it depending on the problem whatever you have and the solution how you have written. So, various techniques are there. So, based on those techniques, so that is whether you are writing the iterative algorithm, whether it is suitable for your problem or whether it is going to give you the better result within a fraction of seconds or within a quick with a greater speed. So, whether the parallel programming is going to give you the greater speed or else the recursive algorithm whatever you have written, whether it is going to give you the result in a greater speed. So, that we need to think of. And the another one is the size of the input. So, that is also the major thing. So, we will discuss, okay. But here whatever I have listed here, these are machine dependent one. So, that means that whenever as a developer, so whenever we are thinking, of course we need to think of this, but the thing is whenever we are solving problem, so according to our problem we are going to solve, right. So, we won't bother about what other person is using, so what kind of machine he is using, so we can't say that. So, today we have a 64-bit machine, so in the next generation you may get a higher speed one, okay. So, for that reason we can't have a control over these aspects, whether we can have a better system. So, that is the programming language. So, a number of programming languages are there. So, because of that reason it is we can't control these all things, the compiler. So, a number of compilers are there for execution of your program, right. So, we can't have a control over this, so that we are only concentrating on the input size, that is the size of the input whatever we have given to the algorithm. As we know that, so whenever we are writing the algorithm, so but only writing the algorithm is not sufficient, right. So, if you want to write the algorithm, that is if you want to get the solution for your problem, you should know what is the input, what is the procedure and what is the expected output and all, right. So, if he doesn't know about these things, how you will find out whether that particular algorithm is yielding the correct result or not, right. So, because of that reason, the time efficiency or analyzing framework consider that this as a major key ingredient to find out what the time efficiency, okay, or else for analyzing your algorithm, okay. So, the size of the input is very important. As we know that for some kind of algorithm, whenever we are giving the inputs, so it will work faster, right. So, if it is a smaller input, so the smaller input, then it will work faster and faster. And even some algorithms are there, even if you are giving a larger amount of data, by that time, I mean to say input, by that time it is going to yield you the result quickly. But some algorithms are there depending on the problem, okay. Some algorithms are there, like they are going to give you the result for the smaller input, it works fine, okay, within a fraction of second or a where smaller amount of time itself it is going to give you the result. But some of the algorithms are there, but if you are increasing the size of the input very large, by that time your time also increases, the number of times. So, whatever the operation you are going to perform is also increases, okay. So, it may grow exponentially also. So, that is, so here time efficiency is measured in terms of what? Inputs size or size of the input, okay. And also one more factor is there, that is the basic operation. The basic operation. Let us discuss this input only, okay. So, if you are coming with some sorting problems, but that time if you have a smaller number of values, n values, say for example 100, if I want to sort 100 names, by that time it may the algorithm may give you the result within a second or a quicker way. But if you are sorting the array which is having a huge amount of data, by that time what happens, definitely it will take some time to process it, definitely it will take time, okay. So, it will be slower the efficiency, so efficiency will become lower, okay. So, time will grow in the sense what, your efficiency decreases. So, definitely, so input plays a major role for analyzing your algorithm. If you consider the searching, there also if the array size is very large, by that time definitely, so it will take a longer amount of time, okay. So, next is the basic operation. What is the basic operation is? So, basic operation is nothing but, see the procedure, whenever we are writing the procedure, how we are representing using some mathematical equation, right. So, that is nothing but your operation, right. So, here in the algorithm, what are all the statement or the operation which takes or consume much larger amount of time to execute your program or the algorithm is called as an basic operation. So, it will takes a huge amount of time to calculate your output, okay. So, that particular operation is called as an basic operation, okay. So, what is basic operation? Say for example, if you want to add two numbers, what is the basic operation? Addition of two numbers. So, what is the operation you are performing? Addition operation you are performing, sum of two numbers. What you are finding? The addition of two numbers only, adding one and first number and the second number, okay. So, like that, okay. So, likewise find the product of two numbers, by that time what operation you are going to perform? So, here in order to find out the product, definitely we are going to use the multiplication operation. So, likewise, so depending on the problem statement also we can define the basic operation, or else so the statement which consumes more amount of time to execute that particular algorithm is also called as in what? The basic operation, okay. So, usually this basic operation is present in the innermost loop of the iterative algorithm, or else it will be the recursive calls, how many times we are going to call in that particular area, it will be there. So, that is called as a general case. In the general case, the basic operation will be present. So, basic operation might be the addition, subtraction, multiplication, or division, or it might be the comparison. So, these are all the some of the basic operation, addition of matrix, addition of matrix, multiplication of matrix. So, if you consider a number of problems, definitely, so you will end up with the basic operation like addition, subtraction, multiplication, division, and then the comparison only, or sometimes the assignment also, okay. But usually the comparison, addition, multiplication, division is the basic operation. Okay. So, now here if you consider this inputs, so how many times you are going to execute is also, so how many times your basic operation is going to be performed, that will give you the running time of that particular algorithm. So, the running time is nothing but your time. So, that is time efficiency itself. The time efficiency of the algorithm is based on what? The input size as well as the number of times the basic operation executed. Okay. So, that is also called as, and we can define our time efficiency like this also. The number of times the basic operation executed is also known as time efficiency, or the running time of the given input for the n input. So, usually we will call the size of the input by n itself. Why? Because whatever the algorithm you take, so generally we will specify the size of the input by n only. Okay. So, like n is equal to some integer values 0 to n. So, that is 0, 1, 2, 3, 4, 5, 6 like that. Okay. So, usually we are representing like this. So, finding the sum of n numbers. So, n is nothing but what? The size of the input. Okay. So, n usually we represent n by what? The input size or size of input. Therefore, how to calculate this running time is, so we are going to represent using the equation T of n, which is approximately equal to B into C of n. B into C of n, where this function T of n represent the time efficiency function. And then n, this is nothing but what? The size of the input, right? So, B is the constant value which holds the execution time. Execution time of the basic operation. How much time it has taken to execute the basic operation. Usually we are representing that using units. So, that is, here we can't say that 1 minute or so 1 second like that. Okay. So, for that we are saying 1 unit of time like that. Okay. And next 1 unit of time, 2 units of time. So, it is depends on the number of basic operation you have. Okay. So, next is C of n. So, C of n is nothing but the number of times the BO executed, that is your basic operation executed. Using this equation we can find out the time efficiency or running time of your system, okay, sorry, algorithm. So, that is T of n, which is approximately equal to B into C of n, where T of n is the function which gives you the time efficiency function. N is the input size, B is the constant value. So, how much time it is going to take to execute the basic operation. Single iteration, how much time it is going to take, that is the constant B tells about. Next one is C of n. C of n is nothing but the number of times the basic operation executed. So, if you are adding 2 numbers, only 1 iteration, but if you are adding n numbers, by that time how many iterations? It depending on the n values, right. So, that much time your basic operation sum, that is addition, is going to be performed, that is the number of times the basic operation executed. Okay. And here one more question arises here, that is, does your algorithm only depends on the size of the input alone? No. Sometimes for the some kind of problem, yes, definitely yes, but for some kind of problems are there, so it is also based on, of course it will be depends on the input size, and also it will be based on some other factors. Okay, so for some other factors, if I take the example, then only you can understand. I will take the example, but if it is your algorithm efficiency is also based on some of the factor, means then you need to calculate the time efficiency in terms of worst case, best case and average case. So, you need to talk in terms of what? Three terminologies, that is worst case, best case and average case. So, using these cases we need to identify what? The running time or the time efficiency of your algorithm. Are you getting? So, that is the worst case, best case and the average case will occur whenever your algorithm efficiencies depends on input size as well as on the another factors. Okay, so let us see what is that worst case, best case and the average cases. So worst case is nothing but the algorithm which takes lesser amount of time to execute your algorithm, then the algorithm efficiency comes to the best case. So which takes less amount of time. So algorithm which takes less time or least time to execute your algorithm is called the best case efficiency. Okay, so what will be the worst case? Definitely, if it is the least one, then the highest one. So that is the highest time. The longer time we can say, highest or longer duration. The algorithm which takes the highest time for calculating your algorithm or getting the solution for your algorithm, whatever the time it has been taken, then it will be considered as an worst case of that particular algorithm efficiency. Okay, so best case, worst case and average case. Usually as your input grows, your algorithm efficiency decreases, right? So the efficiency will also grows exponentially for the some kind of problem. So here the behavior changes in your algorithm is considered in terms of order of growth of the algorithm. So as I said, as your input increases, sometimes time is also increases. So, okay, so for such kind of time, so in that time we are going to represent the algorithm efficiency in terms of the order of growth of the given input n. So, if you are having the input size n, then the highest order degree of this highest order degree of that n is going to be considered as an order of growth of your algorithm. So, the efficiency of the algorithm can be represented using the order of growth of the algorithm. What is this order of growth? That is nothing but as your input grows, the efficiency of the algorithm also grows. That means that the number of times the operation will grows here. Okay, so that change in behavioral of the algorithm as your input changes, that behavioral study is called as an order of growth of the algorithm. So that is, so if you are drawing a graph, input versus your time, then time versus your input, so your curve increases as your inputs grows. Okay, so time also increases as your input grows. Okay, so that is called as an order of growth. So if you are increasing the order of growth, then you can say that, say for example, your T of n, how to calculate T of n? C into B of n, right? So that is, B into C of n, right? So say for example, if it is belongs to, it is equal to n square. You have found that n square is the equation. Okay, so you have found the value that T of n is equal to n square by using some formulas. You have obtained the n square, assume like that. Okay, but that time, what is the efficiency of this algorithm is, the order of growth of this algorithm is quadratic, since its time efficiency is n square, double the time of the input we have given. So say for example, T of n is equal to n, then the order of growth of this algorithm is linear. Okay, as your input grows, time grows, like that only. Linearly it is going to be improved. That is the order of growth of your algorithm. So here we have a order of growth like log n, n log n, n square, n cube, 2 to the power of n, n factorial, these. Okay, so these are the order of growth of the algorithm. Usually the order of growth of the given input is going to be represented using the highest order degree of that particular n value. Okay, so here that will be represented, either it might be log n, usually the running time of the algorithm will be represented using log n times, or n into n times, that is logarithmically it is growing, so linearly, so n into n log n square, cubically it is increasing, that is n cube times, and then 2 to the power of n times, exponentially it is growing. So like the example like tower of an eye problem, or else finding the factorial of a given number, those are all things. If you consider that, so the efficiency of the algorithm will be 2 to the power of n and n factorial. This will grows exponentially as your input grows. Okay, so now let us go back to this, the different cases. So input as well as depends on the extra factor. So then we will come across what worst case, best case and average case. So in order to explain that extra factor, I would like to take one example, simple example, that is the problem like finding the given number in a list. Okay, finding the element, or we can call that one as a key element in the given list. So say for example, let me consider 10, 20, 30, 40, 12, etc. Okay, so list usually represented using the data structure array. This is an array A which having a 5 different numbers. So 10, 20, 30, 45 and 12. Okay, so now we need to find out the element. So for this we can write the algorithm. So the entire algorithm I am not going to write, the pseudo code I am going to write here. So here if the key element, so here what we are finding for the key element, let us assume that key element is equal to 10. Okay, so I would like to take 3 different values. So assume key is equal to 40, or let me take 30. So key is equal to 12 or 15. Okay, so 2 different items I would like to take. Okay, now so how to write the key elements or the algorithm? we need to check whether the key element is present in the array or not. Array, so if you are writing the array, so continuously we need to keep on checking the all the elements, so that we need to go for looping statement. So let me use the looping statement. So indices value I, so usually I is going to be used to access the array element, that is indices value starts with what? 0th position. 0 to how many elements are there? 4. 4 is nothing but, if you consider n is equal to 5, then 4 is nothing but n minus 1. It is going up to n minus 1 position. We need to do what? We need to do, so whether my key element is present in the array or not, we need to find out. So in order to do that, what we are doing? We need to do comparison operation, whether it is equal or not, whether it is equal or not. If it is equal, the element has been found. Okay, so this is the procedure. Okay, so now A of I. So A of I, key is equal to A of I. We need to check. So if it is true, then what is the action? So we need to return the key position, or else key position is nothing but what? In the ith position the array element is present, like that. Or else you can make use of the boolean value true or false, like that. Okay, so it is depending on the problem statement whatever you have. Okay, so next is else. We are going to return -1 by saying the array element does not, key element does not found in the given array. Okay, so let me trace for this inputs. Okay, what is the input? 10, 20, 30, 45 and the 12 is the array of elements. Now I need to find out what the key elements 10 for the first iteration. Okay, so first key value we need to found is, first input is key value is 10. So key is 10 is equal to A of I. I is 0. In the 0th position you have what? 10. So 10 is equal to 10. So 10 is equal to 10. True. If it is true, what is the action? Return I. Yes, I have found the element. What about the comparison here? So we are not comparing the elements that is present over here. The remaining elements are not going to be compared with the key element. Why? See, I have done with my job, why should I bother about other element, right? So this is what the best case is. If the key element or the number of times the execution which takes less time, then it is called as the best case. So the best case is if the key element, so if you are talking in terms of this problem, that is the searching problem, then if the key element is found in the first position, then it will be considered as what? The best case. Why? Because the number of times the basic operation executed for how many times? Only one time. So next is the key element is 30. So let me find that. So for that execution starts with when I is equal to 0. Okay, when I is equal to 0, 10 is equal to 30, false. So I gets increments. So it is not going to return the I. Instead of that, I gets increments. I is 1. So in the 1st position we have 20. So 20 is equal to 10. This is also false. If it is false, I gets increments. It will comes to here. So now key element is 30 and the ith position value is also 30. So 30 is equal to 30. Therefore, the element found at the 2nd position. How many iterations it has been taken place? The basic operation, that is comparison, is done for how many times? 1, 2, 3. So that is the average case of the algorithm. It will give you the in between the best and the average case we have, best and the worst we have. That's why it is called as an average case. Okay, so the algorithm efficiency lies between, so the number of times the basic operation executed is less than the given input only. Okay, then it is considered as an average case. So if the key element found in between the first position and the last position, then it's said to be what? The average case of the given algorithm. So this is best case, okay, of the linear search. Okay, and this is the average case of the linear search program. Okay, and next is, let me take 12 first. Okay, so let me take the value, key value as 12 and keep on comparing the values. So when I is equal to 0, 10, 10 is equal to 12, false. So when I gets increments, I is equal to 1, 20. So 20 is compared with the key element 12, so false. So I gets increments 30, 30 is equal to 12, that is also false. 45, so 12, that is also false. 12 is equal to 12, it is correct, but what is the I value? So I value is 4, that, and don't think about what is the position. Now just go with the number of steps we have did. So we have compared with 10, we have compared with 20, we have compared with 30, 45, and then we have compared with 12. So all possible cases we have checked. So that is, we have end up with the last position. So if the key element found at the last position, how many times your basic operation is going to be performed? Definitely it will be for n times. For the given input, it is going to take n amount of time. So that is called as an worst case of this algorithm. Are you getting? Okay. So what is the best case, worst case and average case, which takes the least amount of time to execute your algorithm, is called as in what? Best case. If you are considering in terms of problem, then what is the best case of this searching algorithm? Best case is if the key element found at the first position itself. So next, the average case, in between, if you found the key element, then it will be the average case. What about the worst case? The algorithm which takes the highest amount of time, longer amount of time to execute your algorithm is considered as an worst case. Then what is the worst case in this linear search? If the key element found at the last position, or else if the key element does not found at the last position, then it will be considered as an worst case. Then what is that extra factor here? Can you tell me that? Yes, so that is nothing but, of course it is based on the input. Along with that, the key comparison, whatever we are doing, based on the key value, we are stopping the algorithm, right? For the first iteration, see, when key is equal to 10, it has matched with the 10, the array elements, so we are stopping there itself, right? So the algorithm efficiency, sometimes the algorithm efficiency is based on input as well as the extra factor for some kind of problem, not for all kind of problems. Okay, so here only best case first position, worst case the last position, or unsuccessful search it might be, and then average case, so in between any of the position. Okay, in between the best and the worst, which lies between. Okay, this is about the worst case, best case and average case. So this is about the how to analyze, or what is the framework for analyzing your algorithm. So in the next coming session, we will work on how to analyze a recursive algorithm and non-recursive algorithm. Thank you.